Hey everyone, in this video we're going to be covering the TOWFL challenge. This challenge was originally part of CakeCTF 2023, but the folks at Alpaca Hack are graciously hosting it, so we can access it whenever we want. The challenge was written by PTR Udai. We've seen them a bunch of times, and they make really good challenges. The challenge says, do you speak the language of wolves? Prove your skills here. We're given a download file and a instancer. So this is my favorite type of challenge where you're given code that looks very normal, acceptable. Like, it just doesn't seem like there's any security issues, but there's one there. And like, I mean, maybe I shouldn't be saying this out loud, but I'm pretty sure if I was reading this, like I used to be a security engineer at a company. I'm pretty sure if someone opened a PR with this code, I just don't think I would have, like, and I'm just doing a quick scan of the code to see if everything's okay. I don't think I would have caught this issue. Like, maybe I shouldn't be saying this out loud, but like, it's just like totally acceptable looking code. And it's not until you like think a little bit more do you actually catch the issue. So my favorite type of challenge, innocent looking code that, you know, is actually vulnerable. For this challenge, so it says test of wolf as a foreign language. This is a play on, I assume it's a play on TOEFL, which is test of English as a foreign language, which is an exam that I think you have to use as like an entrance exam to go to a English speaking university. But you can click start exam. And so I assume this is how the exam is formatted. There's going to be a passage. This is in wolf speak, I guess. I don't really know what this is. And then it has a list of questions. So for this challenge, there are 100 questions. So there's 10 of these pages and they each have 10 questions. And the way it works is you click through all 100 of them, and if you get all 100 correct, it gives you the flag. But there's nothing discernible about this, and we'll see on the back end, it's just randomly picking which one is the correct answer, so you're not supposed to decipher this or something. Like, we actually have to break into the web app. There was that download file. The download file gives us a Docker Compose. You can just do Docker Compose up to play with it. And we can see right off the bat, there are two things. Actually, I'll go to Docker Compose. There is a Redis and there is a challenge. So when I first opened this, I thought it was going to be a Redis injection. Like, why are they using Redis? One of my favorite things, again, I love the Alpaca Hack platform, and I mean, PTR Udai does this on a bunch of his challenges. The Redis config file says to CTF players, you do not need to check this file. So thankfully, while you're doing the CTF, you don't have to go through these config files, which is always annoying during a CTF. So cool. So the issue is not directly in Redis. I mean, it could still be a Redis issue, but it's not some Redis config issue. And here is the source code for the server, which is the meat of the challenge. Again, it's all pretty standard code. We have a index.html. We have the route to start. So it's going to generate a session if you don't already have a session, and then it's going to generate the challenges for you if you don't already have challenges. And when it generates the challenge, it just puts them into Redis based off of your EID, which I guess is your exam ID. Seems sensible enough. This is how you can get questions. And so for all those questions, it'll return them. This is how you can submit your answers. So there's 3 stages, I guess. There's you start an exam, you submit your answers, and then later you get your score. So this is the code to submit answers. All pretty sensible stuff. It's going to check for your ID. It's going to load those challenges from the Redis database. It's going to see how many you get correctly, and it's going to save the result into some like results array as part of the challenge. And then it's going to save that back to the database. And when you're all done, you know, submitting all the answers, you can ask it to be scored. And this is like the final stage. It's going to make sure that you have a valid session. It's going to load all of the challenges that you already saved. It's going to calculate your total score, and if your total score is 100, you get the flag. If not, it says nothing. To make sure that you don't do a replay attack, it's going to clear your session, and then it'll do a response. This is how it generates the challenges. Again, it's using random. I thought at first this was a rand crack, like you're supposed to, there's a Python library called randcrack, and there's another one, I think it's called like untwister, that uses symbolic execution. I thought maybe that we were going to have to reverse this random number generator, in which case, to be honest, I thought the challenge was kind of lame at first because I thought this was the answer, and I just didn't want to do a randcrack. And then this is just to connect to the Redis, and that's it. So maybe you saw the issue, maybe you didn't. I definitely did not see the issue. The issue is in here, and the issue is specifically on this line. Like I said, I love this challenge because this is like just such sensible code. Prevent the replay attack. So obviously you've already answered all the questions. If you could submit multiple times, that would be pretty bad. And so to prevent that, they just use flash session clear, which seems like the method would do what you expect, but it does not do what you would expect at first glance. And so the way Flask Sessions work is they are client-side cookies, which means that the server is essentially stateless. So in this example, we can actually just take the cookie and look at it. So we have session. Let's go to CyberChef. We're going to decode the cookie. But basically, the server stores all the information about that user in the cookie, and then it just forgets about everything until that user comes back with the cookie, which is what we mean by client-side cookie. And so then they store everything. In our specific case, that would be that EID parameter we saw. It would be stored in this blob of text, and we're going to decode that in a second. But this is the first part of a Flask session. Then there is this part. This is the timestamp, just base64, and this is the hash, which in this case would be HMAC. So like I said, we talk to the server. This server gives us a cookie, and the way this interface works in Flask, it's super nice, is it's just flask.session, and you can assign it or read values from it. Flask is going to do all the stuff on the back end for decoding and verifying that the session is correct and everything, but you just assign a variable into this Flask object, and later it is going to assign a cookie that looks like this. So super cool. Like I said, we can decode this. This period at the front means it's zlib encoded, so we have to do some zlib, but pretty simple. We're going to take this. We're going to do from base64. This is a URL safe base64, and then we want zlib, and we want to inflate it. And here we go. So this is that data. Like I said, Flask is not saving this anywhere. It is just saying, like, here's your cookie. Next time you talk to me, I'm going to load the EID so I know who you are. Cool. So that's the Flask session. We can go through the code. It's really not that exciting. I went through it just to see if there's anything cool happening, but I think it works kind of how you would expect. There's a salt, which is interesting. There's the key derivative thing. One thing I found interesting is Flask is actually pretty cool about how it does the vary header for cookies. So Flask actually checks to see if you access that cookie, and so it knows that it should insert the vary header to prevent cache poisoning attacks if you have a proxy or something caching responses, which is pretty cool. Like I said, if you delete the session, which is what happened, it'll send a delete cookie, which is just an empty cookie for that cookie session. Again, it doesn't actually delete it. Flask isn't gonna like see that cookie in the future and be like, ooh, that's a bad cookie or something. Like, it doesn't care, it just sends an empty cookie, and it's like, sounds good, you know, completely stateless. And then if you changed your cookie, it'll add that new cookie. And again, it'll set the cookie. And here it's using that serializer. The serializer actually happens in a library called It's Dangerous. And this is just a library for essentially doing the HMAC, but in a cleaner way, doing the HMAC on that cookie so that the client can't tamper with it. But you saw we are able to view what's in these cookies, so you can't put anything secret in these cookies. I really should just put an identifier in there, because users can view them, but since it's signed with that HMAC, users can't modify it. And the signing key for that HMAC which is the secret key here, which is why it's important that attackers don't know this key, because if they have this key, they can do the HMAC themselves and they can generate arbitrary sessions. Cool. So going back to that vulnerable line, the prevent replay attack line. So this will clear that current dictionary, our session dictionary. And so the EID won't exist anymore, and it'll send back, the delete cookie, so an empty cookie. But again, thinking about how Flask sessions work, if we just save that cookie, we can use it again. Like, it's not clearing the database. It's not like remembering that this is a used session or anything. We already have a valid cookie, and there's nothing stopping us from just reusing that EID and submitting it again. Once you realize this trick, the rest of the challenge is very simple. We're just going to go through answer by answer, see which one is the correct one, see if our score increases. If our score increases, we know we have the correct one, and then we reassign the cookies again so we can do the replay attack, and eventually we get all 100. This is my solve script. Again, nothing too exciting. We're just going to create a Flask session. We're going to start. I print out the cookies and the text. I save the cookies for later. We have to get 100 of them, so I just generate 100 answers. This little chomp utility exists because the API expects that it'll be an array of 10 elements, so 100 elements in total, but they're all in their little subarrays. And then from there, we're just going to guess. There's, I think, up to 10 possibilities for each answer. I'm not too sure. But for each one of those, for each 100 questions, we're just going to give it a random guess. We're going to reassign the cookies to our session. We're going to do the submit and then the score. We're going to see if our score went up, and if it did, we found a valid answer, and we go on to the next question. I can run. I mean, it's not too exciting, but Python 3 solve. And it'll go all the way through. You can see our score was increasing from 96, 97, 98. You can see we got 99 wrong a bunch of times until we get the correct one, and then at the very end, we get the fake flag redacted. So anyways, fun challenge. Thanks again to Alpaca. I guess thanks again for CakeCTF for hosting this challenge originally, Alpaca Hack for hosting it now, and Peter Udai for creating this very fun challenge. So thanks.